Genesis of ECG waveforms, depolarization and repolarization in the heart.
The ECG records the heart's electrical activity. To understand its waveforms, we look at how depolarization and repolarization move through cardiac muscle fibers. At rest, the cardiac muscle is polarized. Both electrodes sense the same potential, so the ECG trace is flat. When depolarization begins, the inside becomes positive. As the wave moves toward the positive electrode, the ECG deflects upward. Once the fiber is fully depolarized, both electrodes sense equal potential again. The ECG returns to baseline. Repolarization restores the resting polarity. Because it moves in the same direction as depolarization but reverses charge, the ECG deflects downward. When repolarization is complete, no potential difference exists, and the ECG line flattens again. Depolarization and repolarization waves in the atria and ventricles generate the P wave, QRS complex, and T wave on the ECG. Now that we understand electrical changes inside a single cardiac muscle fiber, let's move to the whole heart to see how these events create realistic ECG waves. In lead 1, depolarization toward the left arm produces a positive deflection, while repolarization moving away produces a negative one. These principles explain how cellular events create surface ECG waves. The heartbeat begins at the sinoatrial node. Depolarization spreads across the atria toward the positive pole, generating the gentle upward P wave. The impulse slows in the atrioventricular node. Then depolarization moves through the septum from left to right, away from the lead, producing the small negative Q wave. The main ventricular depolarization wave shoots downward and to the left, directly toward the positive electrode, creating the large R wave. As the final region depolarizes away from the lead, the ECG shows the brief negative S wave. When the ventricles are fully depolarized, no net current flows. The ECG flattens into the ST segment. Repolarization begins in the region that depolarized last. The wavefront moves upward, but charge reversal makes the T wave positive.